Good morning, everyone. Today, me and my team are going to present our poster titled Continuous Design Evaluation for Smart Home Products. This aligns with our syllabus topic Evaluation of Design and focuses on iterative improvement within IoT and smart home appliances. So, let me begin by explaining the core idea of the poster. Smart home technologies are becoming increasingly common, from smart bulbs and thermostats to door locks, cameras, and voice assistants. However, despite the rising adoption, the user experience is still fragile and fragmented. People often face confusing setup, inconsistent performance, and concern about privacy and data security. This poster argues that design evaluation cannot be a one time activity, it must be continuous, data driven, and iterative. In this section, I highlight the problem space that makes continuous evaluation essential. We see four different statistics here. 60 to 70% failure rate in IoT projects. This is primarily due to the poor user centric design and weak market fit analysis. Second, 1 in 3 users struggle with setup. Initial configuration in one of the biggest friction point in smart home adoption. Third, 45% of users have privacy concerns. This leads to limited usage or even incomplete avoidance of smart features. Fourth, under 30% adoption rate for complex ecosystems. Most households only adopt the simplest devices. Anything that requires multi-device coordinations or advanced routines sees a steep drop-off. Together, these statistics clearly shows that smart home products fail not because of technology but because of design gaps. Usability, trust, and real-world performance needs to be improved.
This panel outlines the 7 major criteria for evaluating smart home product design. These directly relate to the syllabus themes such as functionality, ergonomics, safety, cost, and aesthetics, contextualized for IoT. Now, let me briefly walk through them. First of all, is the usability and learnability, ease of use, intuitive controls, and a smooth learning curve. If users cannot set up or operate the product quickly, adoption collapses. Second is the reliability and stability. Minimal downtime, consistent performance, and strong error handling. A smart device that works inconsistently feels worse than a normal device. Third is the security and privacy. Safe access, clear permission flows, and transparency of data use. Trust is central in any home related technology. Interoperability. Smart homes are multi brand ecosystems. Device must work seamlessly across platforms, apps, hubs, and routers. Fifth is the accessibility and inclusivity. Design must support diverse users, older adults, beginners, and those with varying abilities. Simple language, readable UI, and assistive features matter a lot. Energy and sustainability. We all know energy efficiency, environmental impact, and long device life cycle, and those are very important in this kind of scenarios. Next is the emotional comfort. The product should reduce stress, not increase it. A sense of control, comfort, and positive emotional experience is must. And the last is the cost value perception. Affordability versus perceived benefit over time. So users constantly compare cost with value delivered. These criteria these criteria ensure design evaluation is holistic, covering technical, functional, emotional, and environmental dimensions. The heart of my poster is the iterative evaluation loop, represented by an infinity symbol. This shows that evaluation is ongoing, not linear. It consists of 4 stages. The first stage is observe and design. Methods used are contextual inquiries, user interviews, market trend analysis, problem framing. And here the goal is to understand real user problems in their real environments, not assumptions in the lab. The second stage is prototype and testing. Methods used are usability testing, lab or remote, A/B testing, interactive prototypes, heuristic evaluation, etc. This stage helps catch issues early before development costs can arise. The third stage is launch and measure. After launching, evaluation continues using telemetry and analytics, usage data, customer feedback channels, app reviews and ratings. This helps identify where real users struggle and what features are underperforming. And the last stage is learning and redesign. Finally, insights are converted into improvements like data synthesis, iterative redesign, firmware updates and OTA improvements, feature refinement, etc. Then the product goes through the loop again.
Here, I added a quick case snapshot to make the process more concrete. A high setup failure rate of about 65% and confusing scheduling features. Usability tests revealed unclear instruction and confusing interface cues. The onboarding experience was simplified with clear steps, guided flow, and an intuitive visual scheduler. So the result was setup success increased to 90%. Support calls related to setup dropped by 40%. This demonstrates how continuous evaluation directly leads to measurable improvements. At the bottom of the poster, I have listed 3 concise takeaways. First, a smart home design must adapt to real-world complexity. Second, continuous evaluation reduces failures and builds trust. Third, iteration improves usability, security, and reliability. These summarizes the entire philosophy behind the poster. To conclude, continuous design evaluation ensures that smart home products evolve with user needs, home environments, and technological changes. By combining clear evaluation criteria with structured, iterative methods, company can create smart home devices that are reliable, intuitive, secure, and genuinely valuable. Thank you.